Alright, so let us work through the second part of the lab 1. So in this part I will talk about some of the looping and how to create R functions. So at first let's take a look at the loop and how we loop through in R. So at first in here what I'm doing is I'm creating a object with a 0 value, and then I am subsequently adding 1 to the value and saving it to the same object. So what is happening is that when the original value is 0 and then I am adding 1, I have the value of 1, and then I'm replacing the old value of k which was 0 by the new value of k, which is 1. And then I'm repeating the same task 10 times, and I'm asking the R to print the new value of k every time. So when I do that, I can see the values of 1 to 10 after that. I can also have a vector, and I can ask R to print each of these elements one by one, like this. So now let's work through a relatively more complex example where I have a vector and I want to square the terms and I want to save them in the k square. It is actually very easy to find how to do this. If I simply have this k square, I can have all of these square terms. So see, when I squared them I have these values, but I want to do it in a loop. So in order to do it in a loop, I create another variable or object called k square, and I create a blank vector with the same length as the k object. So I will have 10 zeros in here when I print out this k square. So I'm getting these values. So once I have that, what I simply do is I extract the first value, square it, and save it in the first location of the k square, that means here, and it will save the first value, and then it will loop through and go to the second object, and the second object was 2, and I square it and I get a 4, and I save it in the second location of the k square, and I keep printing all of these, and eventually I print the whole vector that is being saved in throughout this loop. And here you can see when you are printing these k squares, you are getting all of these k square values, which exactly matches the k square value that we obtained before. And you can also print out the k square entire vector, and this will give you these values. See, I have these values. So it is also possible to use for loop in a much more complex scenario. Say for example, if I want to print out all of the colors in each row of the df data frame that we have created, so we can do that. We can also print add some condition. We can print, remember what was our df? Our df looked like this. The first value was not available, and the second value, third value, fourth value, or the fourth number, and then we had a bunch of colors. So we can simply say if I is greater than 2, print out the colors only. So if I is greater than 2, only for these and these, this condition is applicable, but I'm asking to print out only the first value, only the color element from this df. So when we run this, see, only the green and blue are being printed, where green and blue were associated with the 3 and 4 numbers, and we wanted to print only the numbers that were greater than 2. We could also do the same using a subset function. First we subset and number was the variable name in here, and we simply say we want the part of the data set that was associated with numbers greater than 2, and then we can subset the second column because we basically want the colors of these two that are associated with numbers that are greater than 2. So that will give us the exactly same objects. So the first one is basically the subsetted data, and the second one is the only second column of the subsetted data. Alright, now we move on to a bit more complex scenario where we will learn how to write a function. Say for example, similar to before, I have a capital X as an object, and I say that equal to 2, and when I square that it should be 4, but instead of using this square function, I want to write my own square function, say for example sq, and to write that what I need to do is I need to define an argument, and I need to write the function using that argument. So a is my argument, and I'm using a square in a functional form. Basically I'm using this function, but I'm trying to write it in a functional form. Say for example, I can then use this square function, and I can call either a object or some numbers, and I can also call the not available value and try to see what is the square of that term. So when I run all of this, so x square equals 4, and then I am getting the square of x was equal to 2, so that means I'm again getting a 4. Square of 2 is 4, square of 3 is 9, and square of 4 is 16, and square of not available or missing is again not available or missing. We can use this function and the loops to calculate various formulas and try to get the output from that. To do that, we will do some exercises here, but first let me define a vector which is from 1 to 100, and the mean of the vector using the mean function in R, I'm getting 50.5. What I will try to do here is that I will try to calculate the mean of this vector object, but without using this mean function directly. So I'm just going to use the for loop where I am simply adding each element size to ultimately get the sample size, and I am adding all of the values to get the sum of the values. So I'm basically doing it in a complex way where I could simply get the mean using the relatively known function, but I'm using this as an exercise to show you how the for loops can be used to get the means. And basically what I'm doing here is that I'm calculating the n and I'm calculating the sum, and once I get the sum and n, I can simply calculate the mean. So eventually after this calculation, I'm getting a mean of 50.5. So this is a for loop that I'm using to get that mean, but we can also use a function that will do all of this, and that function will be reusable. Let me show you how that is the case. So I am defining my function, and I am defining the argument that will be used to calculate this function. So the only external element that I need is the vector, and once I have that vector, I can simply calculate the means using the same formula as described here, and at the end whatever value that I have calculated, I want the function to return that value. So this is the function that I have created. See, this is the name of the function, and then I have given the vector, because I have defined the vector previously as 1 to 100, and that should give me a mean of 50.5, similar to before. This is somewhat reusable, in the sense that, say for example, I'm creating another vector from 1 to 10, and see 5.5 for the mean of this. You can also check what is the mean of 1 to 10, and that should give you the same answer. So see, I mean, once you create a function, that function is reusable for any values that you want to change. Here is an exercise where I'm using the Kahan's summation algorithm, and if you go to Wikipedia, in the Wikipedia link, you can see they have given you a pseudo code of how to calculate this sum, and basically here I am translating this pseudo code into R functions, and see, some of these variables are exactly defined as it is defined in the pseudocode, but I'm changing. So for example, y is the same, they also defined y, but I'm changing some of the other variables such as cx, sum x, and this tx. This is partly because within R there is already a function known as sum, there is already a function known as c, there is already a function known as t. I simply do not want to override those functions and create any confusion. So whenever I define any function, I try to avoid already existing names that are already used in R. So I'm using this for loop within this function, and when I'm using this, I should get a sum, and this is the sum of the values from 1 to 100. And you can also verify this using the sum function, and you can also verify the mean using the mean function, and you see the same sum I'm getting using the Kahan's summation algorithm as the sum that I get from the usual sum function from R.